Então, muito boa tarde a todos. Bem-vindos à segunda sessão da série de webinars Inovação para a Circularidade, promovida pelo Pacto Português para os Plásticos. Antes de iniciarmos a sessão, e dado que temos connosco entidades que podem não estar familiarizadas com a iniciativa, permitam-me só deixar umas breves palavras sobre a Associação Smart Waste Portugal e sobre o Pacto Português para os Plásticos. A Associação Smart Waste Portugal é uma associação privada sem fins lucrativos que tem como missão potenciar a economia circular nas várias cadeias de valor através da educação, inovação, colaboração e criação de novos negócios. A rede da Smart Waste conta à data com mais de 150 associados das mais diversas cadeias de valor, contando com players nacionais, representantes da indústria, do retalho, academia e centros de investigação, municípios, entre outros. A Smart Waste coordena o Pacto Português para os Plásticos, que é uma iniciativa colaborativa que visa potenciar a economia circular para os plásticos em Portugal através do atingimento de metas concretas. Para o Pacto Português para os Plásticos conta com mais de 115 membros representativos da cadeia de valor nacional do plástico. No âmbito das suas atividades, a iniciativa tem vindo a promover sessões temáticas e transferência de conhecimento, como, por exemplo, a série de webinars Acelerar 2025, exclusiva para os seus membros. Esta série de webinars, intitulada Inovação para a Circularidade, tem como principal objetivo dar a conhecer os projetos de inovação dos membros da iniciativa que visam contribuir para uma economia circular, tendo a inovação como driver. Nesta série de webinars, a participação foi aberta a entidades que fazem parte das associações setoriais que compõem a Comissão Consultiva, bem como às comunidades das universidades e centros de investigações que compõem a Comissão Científica do Pacto Português para os Plásticos. Antes de iniciarmos a sessão, deixo apenas umas breves notas. O webinar terá a duração de 1h15, sendo que após a componente de apresentação, vamos ter o Matias a fazer a apresentação de 2 projetos e no fim de cada um dos projetos haverá lugar a perguntas. No entanto, poderão ir colocando também as questões no chat. Deverão manter, por favor, os vossos microfones desligados durante a apresentação e, pronto, e apelamos também que sejam colocadas as questões no chat e serão respondidas no final de cada uma das apresentações. Portanto, hoje temos o prazer de ter connosco o Matias, da Coca Cola Europacific Partners, a quem agradeço desde já a disponibilidade. Thank you so much, Matthias, for joining us. It's really nice to have you with us to present all these projects. O Matthias is from Coca Cola Europacific Partners, Investments Director. A Coca Cola Europacific Partners Ventures é um motor de investimento em inovação da Coca Cola Europacific Partners, que ajuda a encontrar, financiar e promover soluções transformadoras para apoiar a ambição da Coca Cola Europacific Partners de atingir a neutralidade carbónica até 2040. Apoiam startups e investigadores académicos que trabalham em tecnologias disruptivas. Estão fortemente focados nos 3 principais contributos para a pegada de carbono, nomeadamente as embalagens, ingredientes e energia. Os projetos que vão ser hoje apresentados são o Cure Technologies, que é uma tecnologia de reciclagem avançada que converte plásticos de difícil reciclagem em rPET de alta qualidade, e o Hair Hive, tecnologia de captura direta do ar que retira CO2 da atmosfera para dar gás às bebidas da marca. So, again, thank you so much, Matthias, and also thank you so much, Manuel, from Coca Cola Europacific Partners, and Matthias is from Coca Cola Europacific Partners Ventures. Is that right?
Yes, thank you,
Yes,
Patricia,
great.
for the long intro. I heard a couple of the things that I'm going to talk about. So thanks again for the intro. Boa tarde a todos. I will continue in English. As Patricia said, I work with Coca Cola, and we are the bottler in Western Europe, including Portugal, a member of this group of people. And I'm going to talk a bit about what we do in CCP Ventures. I think Patricia also explained that I will build in a few blocks for questions. So please let me know at those moments or write them in the chat. I will start my screen sharing now. Here we go.
What will a net zero CCEP look like? We're already investing in new and exciting technologies to help us get there, but there is a lot more to do. And we need to collaborate with multiple stakeholders to meet the challenges we face. We'll need to shift to fully circular systems and use renewable energy across our value chain. Our ingredients, such as sugar, will need to be grown using regenerative agriculture techniques, producing crops that are high yield and improve carbon sequestration. We could do this by using AI to generate crops that produce more sugar and use less water and fertiliser. Or we could make ingredients without agriculture at all by using CO2 captured from the air. Our manufacturing will need to be more energy and water efficient, produce no waste and be emission-free. We could do this by generating on-site electricity from wastewater and collaborating with others across industries on new technologies. There are so many opportunities as to what our packaging of the future could look like. Our packaging will need to be perpetually recycled and eliminate the need for fossil fuel inputs. It needs to be part of a fully circular system, which includes reuse and refill. It could be made from different bio-based or biodegradable materials, and we could even develop packaging from CO2 we capture in the air. The transportation and distribution of our products will need to be supported by vehicles that use renewable fuels and renewable charging infrastructure across all of our markets. We could even explore entirely new and innovative methods of delivery and supply. And our cold drink equipment will need to be as energy efficient as it can be. Our coolers will need to be plugged into customer outlets powered by fully renewable energy. We could harvest power from the air to halve a cooler's energy needs, create new coolers with even lower energy consumption, or figure out a way to chill a product without using a cooler at all. There is so much we need to do, and there are so many exciting opportunities, but we can't do it alone. We'll need to work with suppliers, customers, peers, policymakers and civil society to drive this change. It starts with us. Join us now on CCEP's journey to net zero by 2040.
Matthias, we cannot listen to you.
I'll stop sharing and share again. And now
Okay.
without the sound. Now you hear me, right? No. Here we go. You hear me right now? You hear me?
Yes.
Yes. Okay. Good. Okay. So we imagine a future where CCP keeps growing our business and refresh our consumers and customers with carbon neutral drinks in carbon neutral packaging and carbon neutral ingredients and carbon neutral operations. And the stuff that we do in our business that still has a carbon footprint, we aim to compensate with the carbon that we capture from the air. And we, CCEP, exist to support the business in achieving its net zero commitment by 2040. So we work with startups and academics from all over the world to help us get there. We have what we call our sustainable future model. What we use.
Matthias, sorry, you're not in presentation mode. If you could, please.
I think I am.
Sorry. We don't see it like that.
I don't see anything, just my screen. Go back to here. What can I do? Share screen. Window. This window. Share. Do you see? If I go to presentation mode, do you now see the full presentation? Or do you know at presentation mode?
We are watching the PowerPoint.
That's a bit annoying. I don't know how to otherwise do it. Can anyone of the organization help with that?
Maybe you need to share your entire screen.
Let's do that again. Entire screen. Let's do that again. Okay, here we go. And back to the PowerPoint. Here. Does this work?
Okay. Yes.
Okay.
Thank
So
you.
here we are. So this is our sustainable future model, as we call it. And it reads from left to right. So over the last 100 plus years, we have taken resources from the earth, like carbon and gas and oil, to build things and have energy. And we believe that over the next 100 years or so, we will use the air around us, the nature, to get to our main resources. And that's not just solar or wind, but it also includes CO2 and humidity or air and even latent electricity. So we work with universities and startups to accelerate the technology development to get those resources at scale and as efficient as possible. So we have on the left a couple of our collaborations with both startups, Zeoduck and Airhive, as well as with universities, one in the Netherlands and one in Spain, that are working on direct air capture. With direct air capture, we take the CO2 from the air and then harvest that, and we can do something with it. And there's a whole variety of things that we can do with it. With Airhive, I will talk a bit more about it later on, but the most direct application is to use it as the bubble in the Coca Cola. But also with Berkeley on the top, we work on the conversion of CO2 to sugar. And also here on the right with the Swansea University, we are working to see if they can convert CO2 into polyethylene. And polyethylene is the building block for our bottle tops. So that is very important, that we really try to get everything not anymore made from crude oil. We are focusing on the right side of the page on the three key contributors of our CO2 footprint. That's ingredients, packaging, as well as energy. And within energy, especially the energy of our coolers. You may have seen them in bars and restaurants, the Coca Cola branded coolers. Well, they all count to our carbon footprint. And of course, in countries, especially in Western Europe, where the grid is very green, they don't count as much. But CCEP, or Coca Cola Europacific Partners, also operates in countries like Australia or Indonesia or the Philippines, where the grid is still very much very, very black. In other words, it's all with carbon or crude oil how they generate electricity. Maybe to highlight a couple of them, of more of the companies that we're working with. You may have seen them in the video. One of them is Avalo. They have a AI model to help advanced creation of new sorts of crops. And we are working with them on sugar, because within ingredients, sugar is about 60% or so of our carbon footprint. So we're working with them, and what they do is they make new variations by crossing sugar varieties, but they do it in an AI model, so not for real. And then the most probable outcomes with the best results for yield, water use, low fertilizer use, and very few pesticides, they then put in the ground for real and have, the nature with bees working to create those new varieties. And with that, they bring the lead time for new sugar crop varieties down from like 10 to 12 years just to 3 or 4. So we're working with them, and in Australia, we hope to have a crop in the ground by end next year for harvesting in 27. I will tell a bit more about Cure in detail, but let me also highlight Pipeline Organics at the bottom. It's a company that is building a so-called enzymatic biofuel cell. And what does it mean? That means that they have enzymes that can eat the energy, the glucose that we have in the wastewater of our plants, and turn it into electrical energy. So we're working with them, and we on one of our sites in the UK, and they have already tested the first prototype, very small, to see if they can already make a light bulb glow. And I think that's one of the good examples of CCEP Ventures as an investor, because we is not just bringing a bag of money like many other investors do, but we also bring the whole company. So, we give access to our sites to test out things. We can give access to our people and our customers. And of course, the association with the Coca Cola brand also opens a lot of doors to them, to other companies, to partners, to maybe grant funding, etc. So before I go into the first, let's say, use case, are there any questions on this model? I can't see anything. So if you help me, organization, by reading what is in the chat or give the word to someone who wants to ask a question.
I think you can go on, Matthias.
Okay, then I can continue. Sure. So one of the companies that we're working with is a company called Airhive. They're based in the UK, and we are working with them on direct air capture. So that's capturing those CO2 from the air so that we can do something useful with it. They are only existing, I think, for 2.5 years or so, and they have developed their first capturing unit in Canada, and it's being commissioned, so it's already in the startup phase, in warming up, as a way of speaking, to capture 1,000 tons of CO2 per year. This is the picture of what it actually looks like, and we will get on the right side something similar in our site in Barcelona. Our site in Barcelona uses a lot more than the 1,000 tons, but with this we try to get the experience also in our own engineering team, because we believe that in the future, 5 to 10 years from now, most of our sites will be self-sufficient for CO2, because CO2 is a commodity with a very high price volatility and not always easy to get, especially in an island. So, there is, for instance, no production in the UK or on the Canary Islands where we operate factories. So if we could generate our own CO2 there, that could be really, really useful. And of course, it has carbon benefits, because the CO2 that we take from the air doesn't count anymore to our footprint. And the idea is that this whole installation will connect to our existing production line. I have a schematic overview on the next slide where I explain a bit how it works. So it starts on the bottom left, where we have the sorbent. Sorbent is like a grain of sand, and they bring it in the carbonator, and in the carbonator it creates sort of a sandstorm. So this sand is moving around very fast, and it's very porous, so it can absorb all the CO2 that is being blown through it. And then the sand with the CO2 connected to it goes to a calciner, which is like an oven. And with the heat from the oven, the CO2 desorbs again from the sorbent, is being then shipped or being transported to a tank, to a CO2 tank, where it's liquefied. And that's here on the left, the red post-processing. And the sorbent, after it's being cleaned up, it goes again back into the whole flow. And it needs these two enormous ventilators to push through a lot of air, because as you may know, the CO2 in normal ambient air is only 0.04%. So, to get concentrated CO2, you just need to push through a lot of air. But with this installation, we aim to get about 1,000 tons of CO2 per year. And just to give you an idea, that's between 15 and 20% or so of our annual consumption of CO2 on that site. Barcelona is quite a large site of us, so there are smaller sites that maybe just need 2,000 or 3,000, but the Barcelona one is a larger one. So that's how we do it. And of course, this is just one installation with AirHive specifically for the use of CO2. They are also developing much larger installations. They are already designing the 10,000 ton installation and have plans for 100,000 ton installation. And with that, of course, they also are not just getting CO2 out of the air for utilization, but also for permanent storage, because that's what we need. Let's say as global citizens, we need the CO2 that is in the air to get reduced significantly. And there is a lot of direct air capture companies that are working on that. And we made a bet on AirHive. We believe their technology is really working very well and very efficient with regards to energy and space. So that's a bit of explanation on our project Skyscraper. Any questions on this project?
Alguém tem questões que queira colocar? Sorry, cannot see everyone. Well, I have a question.
Yeah.
Is this really is this a high consumer of energy? This model, and what kind of energy do you use to make it running?
Yeah, so energy is a very good question. Energy is the largest part of the operating expense. 80-90% or so of running a direct air capture installation is energy. So this one, and it's a key differentiator between the different technologies. So we have evaluated more than 100 different direct air capture companies, and AirHive had a very competitive energy use. And in Europe, we have, I think, definitely 80-90% plus of our energy is renewable. So that makes it also very efficient from a carbon footprint point of view. In other parts of the world, we're not there yet. But yeah, the combination of renewable energy with a highly efficient process makes it attractive from a carbon footprint perspective.
Okay, and then
any other questions?
And sorry, I think that in the Barcelona site also we have 100% renewable electricity. So as all of our factories in CCEP and Europe, that's a very great point for these kind of machines and these tests.
So, and then you use the CO2 directly on for instance, Coca Cola?
Yeah,
Can
exactly.
You explain a little bit of that?
Yeah, sure. So the CO2 that is captured is already very pure, because this sorbent is designed in such a way that it only attracts CO2, but still we filter it afterwards. And also we have checks to make sure that it matches it's compliant with the specification requirements from the Coca-Cola company to be used as an ingredient for our product. But indeed, it will go into a tank next to tanks from CO2 from suppliers where we currently buy our CO2, and it will just go to the production line. So in about a year from now, we hope to have the Coca-Cola coming off the production line with the bubble made from ambient air.
Okay, great. Some more questions? Mais questões sobre este tema? Se alguém quiser colocar a questão em português, pode colocar e nós fazemos a tradução. Ok, julgo que...
Then I will start sharing my screen again.
Okay.
And
Go on, Matthias.
Go to the other presentation, the other case. So the second case is Cure Technology. So as part of CCP's objective to become carbon neutral by 2040, a very important part of our current footprint is packaging, especially plastic packaging. So we have designed together with the Coca-Cola company, what we call the bottle of the future. And the bottle of the future aim is to not be dependent anymore on fossil-based plastics. So there is 3 resources or 3 ingredients that can make up this bottle of the future. The existing PET bottles that we have, just one like this, they can be mechanically recycled. That's what we currently do. If you look at small bottles in many countries in Europe, they are already made 100% from recycled PET. And this transparent PET can be, is cut into very small pieces and washed, and then under high temperature and pressure, made again into a bottle, or first into resin and then into a bottle. But over time, this mechanical recycling degrades a bit the plastic. So it gets a bit gray, and it may not comply anymore with the quality requirements that we have. So we need to have, let's say, fresh inflow from PET that has a better quality than existing bottles. So there is 2 sources for that. The first one is bio-based. So we have also invested in companies that are building bio-based PET. One of them was earlier in my model on the right, a company called Via Biofuel, and they are using biomass waste to get one of the key ingredients for PET. So that is also something, especially because it's biomass waste, which is currently typically burnt or landfilled. It has a lot of feedstock, which is good, and it's also available in many parts of the world. On the bottom side, we have short loop recycling, and what does that mean? That's one of the technologies that we are working with on Cure. It means that the polymer is cut down into pieces, and in that state, it can be cleaned and repolymerized to become what we call virgin-like PET. It's not exactly virgin, but almost as good as virgin. And with those 3 resources, we believe that in the future, we can keep enjoying Coca-Cola from PET bottles, which have the lowest carbon footprint, generally speaking, but also from a non-fossil-based resources. So let me dive a little bit more into Cure. So this graphic tries to explain the wide variety of recycling methodologies. All the way on the left is the mechanical recycling. So it doesn't, let's say, change the chemical structure of plastic. It just cuts it in pieces, cleans it, and puts it back. All the way on the right, we have ways of recycling that really breaks down the chemical structure of the plastic. Those typically need a lot more energy, and the output is not PET, but it's so-called monomer, so the building blocks for PET. Somewhere to the left, so very close to mechanical recycling, is Cure. Like I said, they don't break down the full chemical structure, only partially. And I'll explain in the next slide what that looks like. So on the blue column is how mechanical recycling works. We melt the plastic. First it's cutted and cleaned, then it's melted, and we put back, we get back plastic out of it. What Cure does, it depolymerizes the plastic. And what does that mean? So the structure of normal plastic, you could compare if it's under heat and with pressure, like sort of peanut butter, so very thick, and you can practically not filter it because it's very difficult to get out dirty stuff. However, what Cure does, they cut it into pieces in so-called oligomers, so that means a chain length of up to 5 monomers. And in that status, which you could compare to olive oil, you could filter it. You could even apply float sink reactors where, the heavy stuff, the dirt, the plastics, the non-PET material floats and can be taken off, and the good stuff stays in the liquid. And then in the same process, they repolymerize that. So they make again, after cleaning it via filtering and so sink float, they repolymerize it and make plastic again from it. So because they don't break it all the way down, it needs a lot less energy. And also very important, they can repolymerize all in one go. So they can, what goes in is PET and what goes out is PET. The good thing is they also can take out colors. So their feedstock, the input for this process can be much wider than for mechanical recycling, because mechanical recycling can only use transparent bottles. But with Cure recycling, we can also use colored bottles like blue or green. We can also use trays that are currently used. For instance, if you buy in some supermarkets your cheese cut or your ham, they put it on a black plate, a black tray. That's also made from PET, and Cure can recycle that as well. So that really helps to get that feedstock, giving it use, because currently it's typically landfilled or burned or downgraded, whereas Cure can use something and keeps the value of it. It's a very technical story, I understand, but this is a bit how it works. And that was the case on Cure. I have a few more slides where I explain what we're looking at over the coming months, but if anyone has questions on Cure, I think now is the moment.
Questões? Alguém tem questões?
We have a question in the chat.
Okay. So the question is, so this recycling has less loss of material and energy?
The key to material loss is, let's say, the quality that goes in. So Cure works with partners that are really good already, that are currently mechanical recyclers. So they are really good in separating the different types of plastics in the first stages of the process. And with that, they make sure that the yield, the yield is very high, so the loss of material is very low. And with regards to energy is a key, aspect of the let's say the impact on the carbon footprint. It's called an LCA, a life cycle analysis, and Cure has done a life cycle analysis to compare its technology with mechanical recycling, but also with virgin oil, and they are, I think, 20% or so less efficient than mechanical recycling, but significantly more efficient than virgin, because virgin oil is just as a very high carbon footprint. So that's why we believe, as the bottle of the future, this 70-80% of mechanical recycling plus 20-30% of Cure is a mix that is let's say best from a carbon footprint perspective going forward. And I see the other question. Yes, this is indeed, some people call it enhanced recycling or chemical recycling. It has many different names, but it's indeed it's similar to chemical recycling.
Okay, so I also have a question. So this technology is already working on practices? Is in operation?
So Cure has currently a pilot plant, and they have been producing batches of a couple of 100 kilos of recycled Cure PET, and they have sent that material to the Coca Cola company in Atlanta for testing to make sure it matches all their specifications, but it's not, let's say, at industrial scale. So they are currently raising money to build a first, I think the objective is about 25 kiloton plant, to get into industrial production, so that we, like a customer, could also use it as Coca-Cola. But they're not there yet. So they're now trying to get this money, and it needs about a year and a half or so to build an industrial scale plant.
Okay, you mentioned that the need of the quality of the material that comes in the plant. Can you explain a little more about that?
So currently in waste streams, it typically is not just PET. There's also PP or PE, or sometimes little bits of PVC or metal. And the key is that recyclers really manage to separate those streams as good as possible. once that's done, and you have a stream, and you have, let's say, a feedstock of only PET, then it makes the process much easier and more efficient. And then it can be color. That's no problem, because color is relatively easy to get out. However, if there's still other plastics in it, they may react, and then it's more difficult, the more effort it requires to make it clean again. So it is inevitable. There will always be a bit of polypropylene or polyethylene or PVC in the stream. That will just always happen. So Cure can handle a certain quantity of that and clean it all out with filtering. But yeah, the better the pre-work, the more energy efficient the Cure process.
Thank you. There are some more questions. Can you see it?
Yeah, the cost. Yeah, that is one of the big challenges. So in CCEP, we believe that in the medium long term, sustainable solutions need to be on par from a cost point of view with, let's say, the existing technologies. Currently, virgin PET is extremely cheap. I think it's less than €1,000 per ton in Europe. And mechanical recycling is significantly more. So that is currently a challenge. CCP, we have our This is Forward objectives to become net zero by 2040, and there's also milestones that we have to become a 100% rPET company. And currently, sometimes there are people asking questions like, why can't we wait a year? Because virgin PET is so cheap, and will be good for the financial results. So that is a difficult thing. Because currently, virgin PET is very cheap. So we're also trying to advocate in Europe to make it more level playing field. Try to support recycling companies, because that's much better for the environment, and try to limit imports from the US or from China and India on virgin PET.
More questions? Okay, I think we can go on a little more.
Okay.
Matthias?
Yeah, I have another slide that shows a bit on what we're working at the moment for the future. This one. So I think there's someone not on mute. Anyway, I will continue talking. In our innovation pipeline, what we are looking at is 3 different areas right now. We look at manufacturing, in ingredients, and in packaging. And in manufacturing is something really exciting. Is a company called Hot Green. They are one of the first that managed to make energy and cost efficient industrial heat pumps. Because currently, if we try to change our gas boilers for electrical ones, it's just that the cost of electricity and gas in Europe there's such a big gap. It doesn't make sense from a business point of view. But with this company, hopefully we can make it work. And their technology is very, let's say, almost ready. So if we invest in them, hopefully in the next couple of months, we could be working with them in about a year or so to try out their technology in one of our plants. Just from, let's say, as a reference, our manufacturing operations I think are less than 10% or so of our carbon footprint. Most of it is external, like I said, with packaging and ingredients. But even though our operations still also form about 10% of our carbon footprint, so it is important that we also look at that. And within that 10%, the gas boilers that we need to clean bottles, etc., and also have a steam and water for cleaning the industrial installations, just use a significant amount of energy. The one in the middle, a company called Mothership Materials, they are working on getting sugar and other useful chemicals out of agricultural waste. So that's still a bit more out in the future. We need 2-3 years probably before we can have that piloted. But they are very keen to working with us because we use a lot of sugar. So if we can get sugar from something that is currently being discarded as waste or being rotten on the field, like here we see apples or bananas, that would be really great if we could give them better use. And the last one in packaging, still quite far out, but a company called Nova Biochem is working on bio-based packaging from paper mill waste. In a paper mill, it's the feedstock is trees, and trees is a lot of carbon, but we can also use that to create PET. One of the two key ingredients of PET can already be produced in a bio-based. There's a factory in Germany that does that, but Nova Biochem is trying to crack the technology to also make that second ingredient of PET fully from bio-based paper mill waste. And if we could do that all at the same location, then we can create PET from biomass, which would be a great advancement, not just for us, but for everything, I think, especially for this group of Plastic Portugal. But like I said, it's still quite far out, but it's also our role. We believe that we need to be early investors to give this type of technology a chance to come to maturity. And that's it. Any further questions?
Very quiet group today.
Any questions from you, from the organization?
Yeah, just congratulations for all these extraordinary projects. I have a question. So, in these projects and these new technologies that CEP Ventures is investing, is there any kind of collaboration with some other organizations, or so you invest and then the technology is, you are the first, you are going to use it first, or is there kind of more open, I don't know. Do you understand my question?
Yeah, I think I do. So for us, the key to success is that the startup that we're working with is successful. We want them to be successful, and we believe that, and the key question we ask ourselves when selecting startups, okay, if this company is successful, would it be a good thing for CCP? And if the answer is yes, then we continue. But I mean, we also make clear from the start that we are not the so-called exit. We are not going to buy them. We invest in them to make them successful, to give them a chance of success, to become mature. And of course, we'd like to be a customer, but they cannot just depend on us. It's very important that they have a product market fit where other companies are also willing to be a customer of the products. It can be competitors, of course, because we're not the only one using PET, and that's perfectly fine with us. So we don't have any, let's say, exclusivity or something, because that would limit the possibilities of the companies, and that's is not in our interest. I think it's also important to say, so we are not a financial investor, we are a strategic investor. So of course, there's nothing strategic about losing money. So we want them to be successful, but the financial return is not what drives us in the first place. It's making sure that the company has success, so we, CCP, can benefit from the technology, reducing our carbon footprint.
Yeah, great. So since we have Manuel from Coca Cola here with us, hello, Manuel.
Hello, Patricia.
So Manuel, can you talk us a little bit more about the Portuguese site and what are you looking at these new technologies and want to invest here in the future here in Portugal?
If you don't mind, Matias, I'll speak a little bit in Portuguese so that we're all
No problem.
same page. Bem, Patrícia, antes de mais, acho que é excelente nós podemos ver um bocadinho sobre a CCP Ventures e a forma como uma empresa de capital de risco, não é? Ou como é que podemos ter este braço de capital de risco que consegue investir em projetos que são completamente inovadores, ok? Mas aqui nós falamos de algo que é muito mais abrangente do que Portugal. A CCEP acaba por ter aqui 31 países diferentes que abrange. e os testes vão sendo feitos em sítios diferentes, ou seja, como vocês estavam a ouvir, numa fábrica em Barcelona, numa fábrica no Reino Unido, portanto, vão sendo vários os testes que vão sendo feitos para aplicar esta estrutura. Lá está, porque o que nós pretendemos é que toda a empresa possa evoluir nesse sentido e possa crescer nesse sentido. A nossa fábrica, nós temos a vantagem de já ter uma fábrica que também é bastante eficiente, okay? E é reconhecida também a nível europeu por isso, mesmo os níveis que temos de eficiência de água, com 0,53 litros de água por litro de produto acabado, mesmo a nível de eficiência energética, os painéis fotovoltaicos, temos investido também muito nesta transição. Nós já temos energia 100% elétrica contratada, okay, tal como todas as nossas fábricas europeias, mas estamos também a evoluir muito na parte de colocarmos os nossos próprios painéis fotovoltaicos e conseguirmos energia já de uma forma aqui estruturada e termos on-site energia elétrica renovável disponível. Também a parte de caldeiras de biomassa, que também é algo que está agora a ser desenvolvido também em Portugal na nossa fábrica. Portanto, acredito que cada vez mais esta redução é importante, mesmo este caminho para net zero, como dizia o Matias muito bem, é um caminho que nos abarca a todos, okay? Nós tentamos antecipar aqui com o net zero até 2040 e já com uma redução em que pretendemos até 2030 reduzir em 30% as nossas emissões, okay? E aqui é importante uma coisa, que às vezes nós falamos net zero e muitas das vezes confunde-se um bocadinho net zero com neutralidade carbónica, ok? São questões completamente diferentes. Nós, numa questão de net zero, nós o que estamos a fazer é uma redução de toda a nossa pegada de carbono, em que o que pretendemos é reduzir até 90% das emissões face ao ano base que tínhamos de 2019 e continuarmos nesta senda de apenas compensarmos ali com os 10% de emissões que realmente de outra forma não conseguiríamos. E lá está, projetos como estes que o Matias nos apresenta são projetos fantásticos para nós conseguirmos fazer este close loop, não é? De tudo o que é carbono, porque realmente é mais uma forma de nós conseguirmos compensar um pouco a nossa pegada. Outro ponto também muito interessante é a questão das embalagens, em que aqui o Matias falava das nossas embalagens, que em muitos países nós já fazemos uma incorporação de RPET bastante grande, ou seja, mesmo em Portugal nós já temos 100% de RPET no PET 500, 100% de RPET nas bebidas sem gás e 50% de RPET nas restantes, okay? Isto excluindo tampa e rótulo, porque não são em PET, mas tudo o resto estamos a falar, todo o formato da pré-forma da garrafa é tudo RPET e já com uma incorporação muito grande de material reciclado. E o nosso caminho, a nossa PET Bottle of the Future, é mesmo isto, ou seja, é nós conseguimos ter uma embalagem em que não precisaria de material virgem, não precisamos dessa dependência. E é um caminho muito interessante e conseguirmos pegar em algo que para os outros muitas das vezes é mau, como pensamos muitas das vezes no carbono, não é? O CO2 e a nossa pegada de carbono, e conseguir incorporar nas nossas bebidas e nas bebidas carbonatadas que precisam desse mesmo CO2, ou transformá-lo em açúcar, onde a sua base é carbono, também são projetos fantásticos e que é importante percebermos que sim, estamos aqui a apoiá-los. Não vai ser apenas isto que nos vai fazer ser neutros em carbono em 2040, mas fazem parte do caminho e vão nos ajudar a nós, e com isto acreditamos que também pode ajudar outras empresas da indústria, seja cá em Portugal, seja noutros países. Daí também este desafio para o Pacto e para também abrirmos aqui um bocadinho este espectro. Lá está, porque tal como o Matias disse bem, isto não é algo que nós queremos exclusivamente ter só para nós, esta tecnologia e esta startup. Nós queremos ok, vamos dar palco a estas startups para elas poderem crescer e continuar o seu caminho. Okay? Daí acredito que é muito importante nós continuarmos a trabalhar sobre isso, abrirmos portas. Eu lembro que no outro dia, na fábrica, na visita à fábrica, houve alguém que eu peço desculpa que já não me recordo o nome, também não sei se está aqui, mas que era da empresa da parte do braço de Ventures da Delta, okay, que também disse, olha, fantástico, Manuel, gostávamos de saber mais sobre isso e gostávamos de perceber se também poderíamos fazer algo também com a CCP Ventures ou trabalhar em conjunto ou algo do género. É isso. Eu acho que é isso o pacto, okay? E é isso que nós temos que transformar e viver aqui. Por isso, é que às vezes é importante esta interação, é importante nós consigamos apresentar estes projetos, mas também que cada vez mais as empresas se abram para se perguntar e para dizer, ok, e se fizéssemos isto? E se tentássemos também trabalhar com Avalo ou trabalhar com AirHive? É possível? Sim, é possível. Estão abertos a isso, querem saber mais. Podem saber mais, contactem também essas startups e contactem-nos a nós. Temos todo o gosto em ajudar e lá está, termos todos aqui uma pegada menor no nosso futuro. Está bem? E, portanto, thank you, Matias, once again. You're awesome. And I love to hear you. Every time I hear you, I discover new things. So, great. Thank you. E, Patrícia, muito obrigado também pela disponibilidade.
Obrigada, Manuel, pelas palavras também e também pelo entusiasmo por estes projetos, porque acho que só com novas tecnologias é que vamos conseguir dar resposta a todos estes desafios e muito grandes que temos pela frente. Desafios ambientais, desafios regulamentares. Já agora, esta questão desta forma de reciclagem, como é que vocês estão a fazer o enquadramento disto por exemplo, com o regulamento de embalagens e resíduos de embalagens? Já fizeram esta análise? Agora, fugindo aqui um bocadinho ao tema, mas...
É outro dos pontos que o Matias também estava a falar há pouco, que é, nós continuamos a defender que Enhanced Recycling, reciclagem avançada, reciclagem química, como lhe queiram chamar, é sempre mais uma oportunidade para muitas das vezes nós pegarmos em resíduos que de outra forma nem sequer teriam qualidade para ser reciclados ou para ser reaproveitados e podermos reaproveitar, ok? E vocês viram que mesmo esta aposta na Cure Technologies é uma aposta desse género, que é, ok, conseguem arranjar um projeto muito mais eficiente, com menos custo e com menos intensidade energética, digamos assim, com menos custo energético, com menos peso nesse sentido, e transformar plásticos que de outra forma iriam para aterro ou para um downgrading, pelo menos, não é? E acredito que isso é o caminho que temos que seguir e continuamos sempre desde a parte de CCEP a fazermos este trabalho que muitas vezes as pessoas têm esta ideia, mas este trabalho de advocacia é muito importante porque por vezes o regulador também desconhece o que é o impacto destas tecnologias ou de que forma que elas funcionam e às vezes até os próprios receios, os mitos que se criam à volta de alguns tipos de reciclado, como eu já ouvi os problemas que tem o RPET. Não tem, o RPET é completamente seguro, é algo que está certificado, está seguro, é completamente válido e é uma solução fantástica para aumentarmos a circularidade. Portanto, apostemos nisso. Acho que o crítico neste momento é não ficar para trás e é não apostar na reciclagem e não apostar no avanço destas soluções também a nível de embalagens. E este trabalho de lobby, este trabalho de advocacy, para conseguirmos fazer com que aumente a quantidade de PET disponível e de recycle PET, seja ele através de mechanical recycling, seja por enhanced recycling, e voltamos a dizer, e o Matias também já tinha dito isso, o nosso principal foco é a reciclagem mecânica. Continua a ser o principal foco, continua a ser a principal ferramenta. No entanto, isso não invalida que não se possam trabalhar outros tipos de reciclagem. E aí é mais uma oportunidade, é mais uma forma.
Ok, obrigada. Não sei se mais alguém se quer juntar à conversa.
Estejam à vontade que isto não é um monólogo. E o Matias também, entretanto, vai percebendo o que nós dizemos, porque ele também fala muito bem espanhol. Portanto,
Exacto.
ele
Ok.
vive em Madrid e também fala um espanhol bastante
Okay,
top.
so if anyone of some other companies from Portugal or some place anywhere wants to contact these startups, these technologies, they are open to receive. Oh,
Yep, please get in touch.
okay. Okay, so again, if there are no more questions, we have 1 hour of webinar. So it was really interesting, I think, to all of us to see these new projects, these new technologies, and to see they can really be real in the few years they probably will be in use, and we are going to drink Coca-Cola with the CO2 directly from the air.
Exactly.
Yes, yes. So, Matthias, thank you so much for your presentations. I hope we will continue talking on the future. And Manuel, muito obrigada mais uma vez também. Foi o Manuel que nos ajudou aqui a fazer estes contactos e também foi o Manuel que em primeira mão nos apresentou estes projetos, portanto, na última visita que fizemos com o grupo do Pacto Português para os Plásticos à Coca Cola. So, thank you so much, Matias. Muito obrigada, Manuel. Muito obrigada a todos por estarem presentes neste webinar, nesta segunda sessão de webinars aqui dedicados à inovação. Vamos entrar agora num período mais de férias, portanto, aproveito para desejar a todos umas boas férias. Vi aqui a Mafalda a aparecer, dar só nota que vai haver uma sessão de esclarecimento no próximo dia 8 na APA, portanto, inscrevam-se
Só tenho pena que não seja online.
sobre embalagens, sobre o regulamento de embalagens e resíduos de embalagem. E pronto, resta-me agradecer a todos e desejar umas boas férias a quem ainda vai de férias e um bom resto de dia. Muito obrigada.
Obrigado, Patrícia. Obrigado a todos.
Obrigada. Thank you, Matias.
Obrigado.